Hi, I am Alonso Torres, a composer and musician from Costa Rica. Today I want to show you a virtual system that I designed to substitute a concert harp with a synthesizer during a performance of one of my works. The system was specifically designed to play the harp's particular glissandi with the synthesizer. It uses a MIDI keyboard, a computer, and an iPad as a control surface. The concert harp is essentially a diatonic instrument. Its strings are disposed like the white keys of a piano. It has 7 pedals that the harpist moves to alter all the notes of the same pitch class. Consequently, a harpist cannot play at the same time a natural and a flat or sharp note of the same name. Even if harpists can change the pedal's position very quickly, this action adds a layer of complexity when performing music with fast chromatic changes. However, this apparent limitation can be used to produce unique musical effects, such as a very particular glissandi. In a harp, you can play this effect within any major or minor scale. Indeed, by using enharmonic notes, it can be played whole tone scale and diminished chords glissandi. Okay, let's see how this is made with a computer. First, I designed in the Plug's Bidule software a modular transposition unit. The MIDI notes received at the computer's input are routed to a cascade of note filters that separate all the notes by pitch class. Each note filter's output is connected to an independent transposing module, which can transpose one semitone up or down the incoming notes. All the transposing outputs are mixed and routed to a virtual sound module that has a preloaded harp sampling, and then to the audio output of the computer. Due to the modular nature of the Bidule software, the audio output and the sound module can be replaced with a hardware MIDI output in order to hear the notes played with a synthesizer or a hardware module according to what you need. Later, using the TouchOSC software, I designed this control surface. It has one button for each one of the transposing states of each note. When I press a button, it sends a MIDI message to the computer interprets it, changes the transposing states of the filters, and then sends back an OSC message to light or to turn off the appropriate LEDs in the control surface. In addition to the Bidule transposing unit, it was necessary to implement a MIDI decoding system to communicate the transposing changes to the transposing models, and then 7 OSC message generators to turn on and off the lights in the control surface. I also added these 3 buttons that can set all the notes in the same transposition state. We have this in the center. It sets all the notes in the natural position. This sets all the notes in the sharp position. And this sets all the notes in the flat position. This is a very useful feature that, of course, a real concert harp does not have. So let's try it on a keyboard. First, the all naturals position. all sharps position. And the all flats position. I now come back to the natural position. To start playing another glissando, a more interesting scale glissando. Let's start, by instance, with a C major pentatonic scale glissando. It's going to be B sharp and F flat. Now let's try a whole tone scale glissando. It's going to be B sharp, F sharp, G sharp, and A sharp. Let's hear it. Okay, and to finish, I'm going to play D diminished chord glissando. It's going to be D natural, C flat, B natural, E sharp, F natural, G sharp, and B flat, and A flat, sorry. Let's hear it. Well, this is how I replaced a concert harp with a synthesizer. I hope you find this interesting, and see you next time.